Hello again. In this video, we're going to talk about some definitions for solving systems of equations. Now, it does not matter which method you use. Either graphing, elimination, or substitution works. Now, you're always going to come up with certain types of solutions. The first one we're going to talk about is in this definition 1 with the consistent system. The system has at least one solution. That means we are going to come up with some sort of value. Then there is an issue where we might not come up with a solution, in which we have an inconsistent system. The system has no solution. These are the two cases. Either we'll have a solution or we won't. Independent equations is our next definition, where each equation in the system cannot be algebraically derived from the other. Now that's a little bit funky, so we're going to have to see an example of that. And the same deal for our next definition for dependent equations. Very, very similar. It says an equation in the system can be algebraically derived from another. So let's go ahead and try two new types of problems. And we are going to, I'm going to get rid of all this good stuff. New layer, please. Layer 5. Okay. So we are going to start off where we are asked to solve. And we have negative x plus 3y equals 6. And we have 3x minus 9y equals 9. Now, it does not matter which method you'd like to use here. You can graph it. Graphing can be challenging sometimes because you got to draw to scale, and I am an awful grapher, so I tend not to like to graph. I'm either going to use elimination or substitution. Now, substitution I only like to use if I have a variable where the coefficient is 1. This guy's negative 1, that's not really ideal. He's 3, he's negative 9. So I don't really want to use substitution. I'm going to go ahead and use elimination. So, elimination, I'm going to identify my two equations. I got 1 and I got 2. And I'm going to cancel out one of the variables who I don't like. And in this case, this is negative, this guy's positive, he's negative. It doesn't matter which one I pick. I'm going to cancel out the x's, okay? So I want to have it where when I add equation 1 to equation 2, these two cancel out. So 3x minus 3x would be ideal. So we're going to take 3 times equation 1. That means we're going to multiply this entire equation by 3. So we'll have negative 3x plus 9y equals, and 3 times 6 is 18. And equation 2 already has everything I could want, so I'm going to leave him alone. Now we are going to add these two equations, one another. This is the elimination method, in case we forgot. And negative 3x plus 3x cancels out. We've eliminated the x value. Oh, and gross, 9y minus 9y also cancels out. We're left with nothing, or 0, equals, and 18 plus 9 is 27. And now you ask yourself, does 0 equal 27? And you would hopefully say, no, it does not equal. So we have an issue. Now, this is usually where, if this occurs, sometimes students panic because they're like, well, then I must have screwed up. Go back, double check yourself, maybe use a different method. So let's say, can I make that a little bit larger? Let's say we get rid of all this garbage I did. Maybe I screwed up. Maybe elimination method wasn't what I should have done. Okay? And really, it doesn't make a difference which method we use, but let's just try another method. Let's say I'm going to do substitution method. So I'm going to take equation 1 again, and I had negative x plus 3y equals 6. I'm going to go ahead and get x by itself and solve for it. So I have negative x equals negative 3y plus 6, and I'll divide by negative 1, so x equals 3y minus 6. And I'll substitute this back into the equation number 2. So equation number 2 has 3 times x. Well, x is now being replaced with 3y minus 6 minus 9y equals 9. And let's see if maybe I come up with a better solution. So I got 3 has to be distributed to each term, so we have 9y minus 18 minus 9y equals 9. Oh, and 9y minus 9y cancels out. We have negative 18 equals 9, and that's not true. So probably we did our other thing right. Actually, if you add 18 to the other side, you have 0 doesn't equal 27. So it didn't matter which method we use, substitution or elimination, both tell me that they must have lied to me from the beginning. This system of equations are inconsistent. Oh, I don't know how to spell. Double check on the previous, scroll back in the video and make sure you're inconsistent spelled correctly. This means we have no solution. Now you can describe no solution in words. You can get fancy and say it's the empty set, or you could say the empty set with the symbol. Either way, whichever way you prefer to write your answer will work. So this is where we have an inconsistent system. Now let's see another type of issue that we could have. And let's get rid of all that crap. Oops, excuse my language. Alright, so now let's say we are asked to solve. And we have, let's do fractions. I know how much we enjoy fractions. We have negative 1/4 x plus 3/4 y equals negative 3/2. And our other equation, we have negative x plus 3y equals negative 6. Let me pause real quick. Okay, so here's our 2 equations that we have. Now, we are going to solve this using any methods. You can graph, once again, gross. Elimination or substitution usually are ideal. So what I'm going to do, because I have fractions involved here, I'm going to use elimination method. And I'm going to make sure that equation 1 here, make sure I'm on the page. Equation 1, I'm going to clear these fractions. And actually, I want to make sure my signs are alternating when I use elimination method. And you notice x is negative in the first one, and x is negative in our second equation. Y is positive in the first equation, y is positive in the second. So, to make life a little bit easier, I'm going to multiply by negative 4 to our first equation. What this is going to do is change the signs so I can have something to eliminate, and also clear my fractions. Let's go ahead and see. So when I multiply negative 1/4 times negative 4, negative times a negative is a positive. 4 times 1/4 is 1. And then I went ahead and made a mistake already. Then we're going to multiply by negative 4 to our positive 3/4. Positive times a negative is negative. 4's cancel out, and we're left with negative 3y equals. Then we're going to multiply negative 3/2 by negative 4. And we have negative times a negative is a positive, and we'll get 6. So that's our first equation. And let's leave our second equation alone, okay? Let's not mess with him. We have negative x plus 3y equals negative 6. Now, looking at this, we can see some issues when we add them together. So when we add these two equations, 1x minus x cancels out. Negative 3y plus 3y cancels out. We're left with nothing. Equals. And 6 minus 6 is nothing. Now, unlike our previous problem, 0 does in fact equal 0. This is a true statement, which means we have a consistent system. But these two equations were the same. And you could see that by multiplying this first equation just by by multiplying this first equation by 4. And I'm going to write it in pink. If we multiplied by 4, we'd have negative x plus 3/4 times 4 is 3y equals. And if we multiply this guy by 4, 2 goes into 4 twice, times negative 3 is negative 6. And we would see these equations can be written the same. Just a little bit of manipulation had to occur. This means we have a solution of all real numbers for our x and y's. Now, I'm okay with someone's writing all reals, but this isn't really the way we want to describe it because x and y depend on one another. So this is not going to cut it when we talk about our ordered pairs. So when we write this, we are going to write it in a kind of a fancy way. So let's see what we'll have here. Let's get rid of these layers. Okay. And let me remind you of our equations that we had. We had negative 1/4 x plus 3/4 y. And my y's and 4's look the same. I apologize. Equals this ugly thing. And we have this guy. Equals negative 6. We're going to write our set as the solution set of ordered pairs, x and y. Because remember, we like to see our answers written as ordered pairs. And as long as, and this is where we're going to pick one of these equations. It does not matter who. I'll say negative x plus 3y equals negative 6 is satisfied. So x and y are dependent on one another. This is the lazy way to do it. Usually you'll see where they've solved for y. In which case, if we solve for y, we'll add x to the other side. We have 3y equals x minus 6. We'll divide by 3, so y equals 1/3 x minus 2. Both of these are acceptable ways of writing our solution. Now, all reals does not say the same things these guys say. These are telling me I have to satisfy one of these equations. And if you notice, both of these equations are the same, so it means that I'm satisfying that same one equation. So any ordered pair, as long as it makes this statement true. And that will be our solution.